For the Egyptians, the sky was not just a void of space, but a sacred realm where the gods lived and governed the world. The sun god Ra would rise every morning to give life to the world and journey through the underworld at night. This journey symbolized Ra's cycle of death and rebirth. The Egyptians tracked Ra's journey to measure time and organize their calendars. Stars and planets were sacred signs carrying messages from the gods. The star Sirius, in particular, held great importance for the Egyptians. The rising of Sirius signaled the flooding of the Nile River, marking the beginning of the agricultural calendar. The Egyptians used this cycle to plan their farming activities. Astronomy in Egypt was not only used for practical purposes, but also for religious and architectural endeavors. Pyramids, temples, and obelisks were aligned with celestial bodies. For example, the sides of the Great Pyramid of Giza were perfectly aligned with the 4 cardinal directions, showcasing the Egyptians' advanced astronomical knowledge. Egypt's astronomers were often priests and scribes. These wise individuals observed the sky to create calendars and align temples and pyramids. For instance, Imhotep was one of Egypt's most renowned scholars. He was not only an architect, but also an astronomer and physician. Using astronomical knowledge, he ensured the precise alignment of the pyramids. He also contributed to the development of Egypt's early calendar systems. Another important figure was Amenemhat, one of Egypt's first astronomers to map the night sky and record the movements of stars. His work was particularly used to predict the flooding cycles of the Nile.
The Babylonians were among the first civilizations to turn astronomy into a science. For them, the sky was like a book carrying messages from the gods, and reading it meant understanding the future. The Babylonians carefully observed the movements of planets and developed complex mathematical models to record these movements. The planet Venus, in particular, held great significance for them. The Venus tablets are among the earliest astronomical documents detailing the planet's movements. The Babylonians were the first to divide the zodiac into 12 signs. These signs were not only used to determine personalities and destinies, but also for agriculture and state governance. For example, the coronation of a king or the start of a war was determined based on astrological calculations. The role of scholars was crucial in Babylonian astronomy. Kidinu was one of Babylon's most famous astronomers. Living in the 4th century BCE, Kidinu studied the moon's movements and developed a highly accurate calendar system. He also calculated the length of the solar year, laying the foundation for future civilizations. Another notable figure was Naburi-Mani, a pioneering astronomer who developed mathematical models to calculate planetary movements. His work played a significant role in the creation of the Venus tablets. Thanks to these, scholars, the Babylonians, could predict planetary movements and use this knowledge for both religious and practical purposes.
The Sumerians were among the first civilizations to lay the foundations of astronomy. For them, the sky was the home of the gods, and stars and planets were considered sacred beings. The Sumerians were the first to systematically observe the sky. The moon god Nana and the sun god Utu were prominent figures in the Sumerian pantheon. The phases of the moon were the primary method for measuring time. The lunar calendar was used to plan agricultural activities and organize religious ceremonies. The Sumerians began recording the movements of planets and interpreted them as the will of the gods. Venus, in particular, held great importance for the Sumerians. The rising and setting of Venus were seen as the descent and ascent of the goddess Inanna. The Sumerian astronomy was advanced by wise scribes and priests. Enheduanna was one of Sumer's most famous scholars. Living in the 23rd century BCE, Enheduanna was not only a priestess, but also an astronomer and poet. Serving in the temple of the moon god Nana, she recorded sky observations, contributing to the development of Sumerian astronomy. Another important figure was Lunana, one of Sumer's first astronomers to record and interpret planetary movements. His work was particularly used to understand the movements of Venus, and this knowledge was passed on to later civilizations. Sumerian scholars used both religious and mathematical methods to understand the sky. This approach greatly contributed to the development of astronomy as a science.
The Maya worked with incredible precision in astronomy. For them, the sky was a sacred realm carrying messages from the gods. The movements of Venus, in particular, held great significance for the Maya. The rising and setting of Venus were used to determine times of war and peace. The Maya meticulously recorded Venus's 584-day cycle and used this information in both religious ceremonies and war strategies. One of the most famous Maya astronomers was Exok. Exok developed the Maya calendar system and recorded the movements of Venus. His work played a significant role in the construction of Maya temples and the organization of religious ceremonies. The Maya also used their astronomical knowledge in architecture. For example, the El Castillo Pyramid at Chichén Itzá was built to cast shadows in the shape of a serpent during specific times of the year. The Maya used two different calendars, the Hab and the Tzolk'in. The Hab was a 365-day solar calendar used to plan agricultural activities. The Tzolk'in was a 260-day religious calendar used to determine the dates of religious ceremonies. These two calendars were synchronized to coincide every 52 years.
Indian astronomy, known as Jyotish, studied the influence of planets on human destiny. For Indians, the sky was the abode of gods and spirits. Astrology was a tool to understand human fate and the will of the gods. One of the most important figures in Indian astronomy was Aryabhata. Living in the 5th century CE, Aryabhata calculated the Earth's rotation on its axis and mathematically determined planetary movements. His work laid the foundation of Indian astronomy. Aryabhata was also one of the first scientists to explain the causes of solar and lunar eclipses. Another notable figure was Brahmagupta. Living in the 7th century CE, Brahmagupta developed mathematical models to calculate planetary movements. His work had a significant impact on Islamic astronomy.
The Chinese viewed celestial events as signs for the future of the empire. Astrology played a major role in state governance. The Chinese calendar, based on lunar and solar cycles, was used to plan agricultural activities and organize religious ceremonies. One of China's most famous astronomers was Zhang Heng. Living in the 2nd century CE, Zhang Heng developed an armillary sphere to record the movements of celestial bodies. He also invented a device to detect earthquakes. His work greatly contributed to the advancement of Chinese astronomy. Another important figure was Guo Shoujing. Living in the 13th century CE, Guo Shoujing refined the Chinese calendar and calculated the movements of celestial bodies with greater accuracy. His work gained significant importance during the Yuan dynasty.
All ancient civilizations saw the sky as a sacred realm carrying messages from the gods. However, the scholars who interpreted and recorded this knowledge played a significant role in the development of astronomy as a science. The sky was not only a religious symbol, but also a guide for agriculture, architecture, state governance, and daily life. Ancient civilizations universally accepted the sky as a language. The sun, moon, stars, and planets were not just physical entities, but also sacred signs determining the will of the gods and the fate of humans. Eclipses, planetary movements, and the positions of stars form the basis of both scientific discoveries and religious beliefs. For example, for the Egyptians, the rising of Sirius signaled the flooding of the Nile, while for the Maya, the movements of Venus determined times of war and peace. The Babylonians mathematically calculated planetary movements. To predict the future, the Indians, on the other hand, studied the influence of planets on human destiny. The scholars of ancient civilizations used both religious and mathematical methods to understand the sky. Wise individuals like Imhotep, Kidinnu, Enheduanna, Aryabhata, and Zhang Heng inspired not only their own civilizations, but also future generations.
Imhotep combined architecture with astronomy while constructing Egypt's pyramids. Kidinu developed a precise calendar system by calculating the moon's movements for the Babylonians. Enheduanna laid the foundations of astronomy by recording sky observations for the Sumerians. Aryabhata mathematically calculated the bee, Earth's rotation and planetary movements in Indian astronomy. Zhang Heng created an armillary sphere to record celestial movements in China. The work of these scholars had a profound impact not only in their own times, but also on later civilization. Islamic and Renaissance astronomy, in particular, was built upon this ancient knowledge. For ancient civilizations, the sky was not just a scientific field, but also a tool that strengthened humanity's connection with the universe. Understanding the sky meant controlling both worldly and sacred events. This knowledge strengthened humanity's bond with the cosmos and laid the foundations of science. Even today, the ancient civilization's knowledge of the sky has a significant influence on modern astronomy and astrology. The sky remains a realm of mystery and discovery for humanity.